Day 533 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3,397, maximum number of distinct elements after operations. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and an integer k. You are allowed to perform the following operation on each element of the array at most once. Add an integer in the range of negative k to k to the element. Return the maximum possible number of distinct elements in nums after performing the operations. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 2, 2, 3, 3, and 4, k equals 2. The output is 6. Explanation says nums changes to negative 1, 0, 1, 2, 3, and 4 after performing the operations on the first 4 elements. All right, y'all, so let's break this down one step further. What we want to do is we want to perform this operation and create the maximum number of distinct elements as possible. So in this case right now, we have 4 distinct elements. We have a 1, we have a 2, we have a 3, and a 4. So just think about it like if we threw this array into a set and we got rid of the duplicates, how many elements would be left? How many elements would be in that set, right? So it'd be in this case there would be 4, but we can increase the number of elements by performing this operation, right? So if we perform this operation, we have k equals 2. That means we can add negative 2, negative 1, 0, 1, and 2 to any one of these elements to make them a different number or a distinct element. So in this case, we add negative 2 to this 1. So let me copy and paste this so you can see over here. So the first thing we would do is we would add, sorry y'all, let me clean this up for y'all. So first thing we would do, we'd add negative 2 to this 1, and now this 1 becomes negative, sorry y'all, now it becomes negative 1. Then we could add negative 1 to this 2, right? And then this 2, or excuse me, we could add negative 2 to this 2, and this 2 would become 0. So we could change this 2 to a 0. Boom. Then we can add negative 1 to this 2, and then this 2 will become 1. So we could turn this 2 right here into a 1. And then we could add negative 1 to this 3, and this 3 will become a 2. Boom. So now, at first, we only had 4 distinct elements, right? We had 1, 2, 3, and 4. Now we have 6 distinct elements. We have negative 1, 0, 1, 2, 3, and 4, right? So we went from 4 distinct elements here to 6 distinct elements here. And since we have 6 distinct elements here, we want the maximum number of distinct elements. We return 6 as our output. So just in case that didn't make sense to y'all, let's take a look at example 2. It's same principles apply. So an example, but in this case though, we can't change the whole array. So in example 2, we have the input nums equals an array of integers 4, 4, 4, and 4, k equals 1. So as you can see, there's only one distinct element in this array, which is 4. And since k equals 1, we can add negative 1. Oh, sorry, y'all. We can add negative 1, 0, or 1 because k equals 1. So then since k equals 1, we can add, it says by adding negative 1 to nums of 0. So hold on, let me copy and paste this again. Boom, we could bring this right here. So we add negative 1. We could add negative 1 to this 4, and this 4 will become 3. We could add 1 to this 4, and this 4 will become 5. Sorry, y'all. This 4 will become 5. And then we can't do anything with these two 4s because if we add negative 1 to this 4, it just becomes 3. We already have a 3. If we add 0 to this 4, it would still be 4, and we already have a 4. And if we added 1 to this 4, it'd become 5, but we already have a 5. So, and same thing with this 4, so it's no need to even touch these 4s. So in the end, it would be 3 distinct elements, 3, 5, and 4. Boom, and that's why the output is 3. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So first thing we're going to check, we're going to see if k is equal to 0. We cannot adjust any numbers. The answer is simply the count of unique elements in nums. So we're going to say if k equals 0, then we can open up the brackets and we can just return a set of, open up the parentheses, passing nums, come outside the parentheses and say dot count. Because remember I said it's just like if we turn this into a set, then we could find out how many distinct elements there are. Boom. Then we're going to sort the input array by, that's just to handle the base case. If that's not the case, then we're going to sort the input array to process numbers in increasing order. This ensures we can assign each number a distinct value sequentially. So we're going to say let nums equal nums dot sorted and put the parentheses. Boom. Then we're going to declare a variable called ands. That'll hold the output. Then we're going to declare another variable, sorry y'all, equal white space. We're going to declare another variable called prev, and we'll set that equal to -1 billion. So we could just say -1 underscore 000 underscore 000 underscore 000 underscore 000, or 1 trillion, doesn't matter, -1 trillion. Sorry, there's hundreds, thousands, millions, billions, trillions. So we're going to set it to -1 trillion. Sorry, y'all. Boom. Now we're going to iterate through each sorted number. So we're going to say for num in nums, we're going to open up the brackets. And if the previous assigned number is smaller than num -k, it means we can safely assign this number adjusted value to become num -k, so without overlapping with the previous number. So we're going to say if prev is greater than num -k, then we're going to open up the brackets. We're going to say ands plus equals 1. Come underneath that, we're going to set prev equal to num -k. Boom. Otherwise, if we can still increase prev by 1 and stay within the num -k, we can assign the next distinct value as prev plus 1, and this ensures the new number is as small as possible but still distinct. So we're going to come right here, we're going to say else if prev plus 1 is less than or equal to num plus k, we're going to open up the brackets and we're going to say ands plus equals 1, sorry y'all, plus equals 1, and we're going to say set prev to equal prev plus 1. Boom. And then if neither condition holds, we cannot assign a new distinct value for this number, and it would overlap the existing ones. So all we need to do is return the maximum count of distinct numbers achievable by coming right here, and all we have to do is say return ands. Boom, y'all. That should be all she wrote. Let's give it a run, make sure it runs properly before we submit it. Let's see, it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. See, and look at that, y'all. 28 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, make sure you get one more look at the code. That's the whole code right there. And I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.